Here is question number 4. Determine the form of partial fraction decomposition. So they are asking what partial fraction decomposition is needed for the following function. Please pay attention. This one is not asking you to solve the integral. There is no integral actually. It's just, you don't even need to solve for A, B, C. It's just need to write it down. Okay, I'm just testing you guys on how to split. So let's work on this. The first linear factor here is x minus 2, which is a repeating linear factor because there is a power of 2. So because of the first linear factor, there will be two fractions. One will be a by x minus 2 plus another one. So use a different constant. Let's name it b by x minus 2 whole square. So because of this first linear factor, which is a repeating linear factor, it's repeating 2 times, we will have 2 possible fractions. Plus, for the third linear factor, here x squared plus 2, this is an irreducible quadratic factor, okay? And it's not repeating. If you notice, the power is only 1, that means it's only here once, not repeating. That means only one partial fraction will come because of this. And also, the numerator of this will not be a constant, it will be a linear function. So we use some constant, let's use c, because we need to use different constants. So this fraction would be written as the partial decomposition as this. A some constant by x minus 2. Whenever the factor is a linear factor, on the top we'll just have a constant. But it was repeating 2 times, therefore 2 fractions, one with denominator x minus 2 and one with x minus 2 power 2. Okay. And for the irreducible quadratic factor, denominator x squared plus 2, it was not repeating, so it only appeared once, one partial decomposition fraction, but the numerator is a linear factor. Let's try the second part of it. Second question is this one. If you notice here, the denominators factors are not given, so the first step is to factorize it. I see x is in each of them, so I'm going to just first factor x, see what's left inside. X squared minus 3x plus 2. Now inside is a quadratic that can be factored further. So we basically need to split 3x as two numbers so that their product is 2x squared and the sum is negative 3. So it will be, I think, x minus 2, x minus 1. So we factored the whole denominator. Now we notice there are 3 linear factors. Each of them is non-repeating. That means, what is non-repeating means the power is just 1 for each of them. So for each of them, we will have each of them will have one partial decomposition fraction. So for the first linear, it will be a by x, plus for the second linear factor x minus 2, it will have some constant by x minus 2. For the third one, it will be just c by x minus 1. So here is the conclusion. If we have distinct linear factors non-repeating, for each of them a separate partial fraction with the constant on the top. If we have a repeated linear factor with the power n, you're going to write those many partial fraction decompositions, like if there is 3, so write 3 partial fractions and keep increasing the power of the denominator until it's exhausted. You don't have to use a1, a2, an. You can use a, b, c if that makes your life easier. So basically all these should be different. If you have an irreducible quadratic factor, the examples would be x squared plus 4 we did, x squared plus 9, which we cannot factor further. Then in the numerator, there has to be a linear factor instead of just a constant. And lastly, if it is a repeated irreducible quadratic factor with power n, so that many partial fractions will decompose, as is the power n here. And for each of them on the numerator, we will have a linear factor instead of your constant, and the power of the denominator, if you notice, increase until we exhaust to the n. I hope this helps.